Hi, this is gonna be my fifth video about solving a system of linear equation using the Gauss Seidel method, because as I always say, the more the better. So, hopes. Let's start with the matrix A, which is the following matrix, as we always do. 4, -1, 0, 0, -1, 4, -1, 0, 0, -1, 4, -1, -1, 0, -1, 4. So is our matrix A, and we have our vector x, which is equal to this 4 by 4 matrix, so 1, 2, 3, 4, 1, 2, 3, 4. So therefore, this is a 4 by 4 matrix. So our vector x is equal to x, y, z, w. So those are the components of our vector x, and after all, we are working in R4, so in 4 dimension space, equal to c, which is of the components -1, 2, 4, 10. So this actually gives us our linear system of equation, which is 4x minus y equal to -1, -x plus 4y minus z equal to 2, -y plus 4z minus w equals to 4, and -x minus z plus 4w equal to 10. So by now you should be pretty familiar with this method. So what we're gonna do here is basically get x, y, z, and w out of those equations without solving those equations. So we're gonna get those variables in function of other variables. So as we always do, let's just do this. So we're basically gonna get 4x equal to -1 plus y, 4y equal to 2 plus x plus z, 4z equal to 4 plus y plus w, 4w equal to 10 plus x plus z. So it's actually gonna give us x equal to -1/4 plus 1/4y, y equal to 2/4, which simplifies to 1/2, plus 1/4 x plus 1/4 z. Z is equal to 4/4, which simplifies to 1, plus 1/4 y plus 1/4 w, and w is actually 10/4, which simplifies as 5/2 plus 1/4 x plus 1/4z. And this is actually gonna give us, well, actually gonna give us x equal -1/4 plus 1/4y, y equal to 1/2 plus 1/4 x plus 1/4z, z equal to 1 plus 1/4 y plus 1/4w, and w equal to 5/2 plus 1/4 x plus 1/4z. Okay, so this is basically our system of equation, and now we can basically start with the iterations, and we always do. So iteration 1, step 1, basically gonna write the table here, and I always do. So iterations and values. Okay, so basically what we're going to do here, you should be pretty familiar. we're gonna pick up some random points, and those are gonna be our guess for x, y, z, and w, and I'm gonna choose 0, 0, 0, 0. So our values of our guess is gonna be x equals 0, y equals 0, z equals 0, and w equals 0. You can choose anything you want as your first initial guess, and it doesn't really matter, as I show you in other videos as well. So we're basically going to start with x equal to, this is the equation for x, so negative 1 over 4, which is a scalar and it's not dependent by anything, plus 1 over 4y, so it's dependent by y, and we're going to use substitute y with the value of our first initial guess, which is 0. So we're basically going to get negative 1 over 4 plus 1 over 4 times 0, which is the value of y, and this is gonna give us negative 1 over 4 plus 0, and therefore x is equal to negative 1 over 4. And then we're gonna do the same thing again, so iteration 1, step 2, and again, those are our values, those are our iterations. X is now equal to negative 1 over 4, y is equal to 0, z is equal to 0, and w is equal to 0. So I'm gonna underline those three because we already found the value of x for the very first iteration, and the equation of y is 1/2, which is a scalar, plus 1 over 4 x, so it's dependent by x, plus 1 over 4 z, so it's dependent by z. I'm going to use x, the newly found value, and z, the one of our first initial guess. And therefore, we're going to have y equal to 1/2 plus 1/4, so 1 over 4 times negative 1 over 4, which is the value we had just found for x, plus 1 over 4 times 0, which is the value of our first initial guess for z. So y is actually going to be 1/2 minus 1 over 16 plus 0, and therefore y is equal to 16, 8 minus 1, so y is equal to 7 over 16. So this is our estimation for y. I'm gonna go on. So iteration 1, step 3, iterations, values. So now we know that x is equal to negative 1 over 4, y is equal to 7 over 16, and we still have z equal to 0 and w equal to 0. So I'm just gonna underline those two. So gotta find z. The equation for z is actually 1, which is a scalar, plus 1 over 4y, so it's dependent by y, plus 1 over 4w is dependent by w. So we're going to use the newly found value for y, and we're going to use our first initial guess for w. So, as I said, z is actually equal to 1 plus 1 over 4 times 7 over 16 plus 1 over 4 times 0. So z is actually equal to 1 plus 7 over 64 plus 0, and therefore z is actually equal to 64. So it's 64 plus 7, z is equal to 71 over 64. And then we're gonna go on again and do the same thing for step 4. So this is for step 4 of the very first iteration. So this is actually gonna be iteration 1, step 4. I'm gonna write our table once again. So iterations, values. So our values are actually x equal to, well, x equal to -1 over 4. No, when x equal to -1 over 4, y equal to 7 over 16, and z equal to 71 over 64. -1 over 4, y equal to 7 over 16, z equal to 71 over 64, and w equal to 0. So we're trying to find w. So w is actually equal to, well, let's just see the equation. The equation for w is 5 over 2, which is a scalar, it's not dependent by anything, plus 1 over 4 x, so it's dependent by x, plus 1 over 4 z, so it's dependent by z. We can use the values that we have just found for x and z in order to get our estimation for w. So, crap, come on. Okay. So in other terms, w is equal to 5 over 2, which was our scalar, plus 1 over 4 times -1 over 4, which was our estimation for our estimation for x, plus 1 over 4 times 71 over 64. Which was our estimation for z. So w is actually equal to 5 over 2 minus 1 over 16 plus 71 over 256. So w is actually equal to, well, can use 256, like the megabytes of RAM. If you're an engineer, you will get that. If you're not, well, sorry for the silly joke. So this is 640 minus 16 plus 71. So w is equal to 695 over 256. Yeah, it's been quite some time since the last time I had a computer with 256 megabyte of RAM. Like, it's been like years and years and years. Those were pretty common back in the days. Anyway, let's go further and complete a full cycle of the iteration 2. So, okay, let's just do this. We're going to do the same thing all over again by using the newly found values for x, y, z, and w. So I'm basically speeding up here, but this is only because, you know, this is the 5th times that I'm doing this, like in a video. So you should be, you know, pretty familiar with the method by now. So we basically said that x is equal to -1 over 4, y is equal to 7 over 16, z is equal to 71 over 64, and w is equal to this newly found value here, so 695 over 256. So let's start again. I'm going to underline all of them, so I'm going to reload all of them, because we're going to have to find all of them again and get a better estimation. So what was our equation for x? Well, let's see. Our equation for x was negative 1 over 4 plus 1 over 4y, and therefore x, our new estimation for x, is going to be negative 1 over 4 plus 1 over 4 times 7 over 16, which is our new estimation for y. So x is equal to negative 1 over 4 plus 7 over 64, and therefore x is equal to 64 negative 16 plus 7, which is going to give us x equal to negative 9 over 64. And let's go on again. So iteration 2, step 2. And now we're going to go on. So iterations, values. So now we know that x is actually equal to negative 9 over 64, because this is the value that we have just found. So basically gonna write x equal to negative 9 over 64, y equal to 7 over 16, and this is the one that we're looking for to get a better estimation. So z is equal to 71 over 64, so you have to find a better estimation for z, and w is equal to 695 over 256. So we're looking for a better estimation for that as well. So we're only underlining those three. Okay, so y is actually equal to, well, let's see the equation. The equation is 1 over 2 plus 1 over 4x plus 1 over 4z. So y is actually equal to 1 half. Was it 1 half plus 1 over 4, right? Yeah, it was 1 half plus 1 over 4. Okay. So 1 half plus 1 over 4 times negative 9 over 64, which was our new estimation for x, plus 1 over 4 times 71 or 64, which was the estimation for z. Okay, so this is basically going to give us 1 half minus 9 over 256 plus 71 over 256. So y is actually gonna be, well, 256 again, 128 minus 9 plus 71, which is gonna give us y equal to 190 over 256, which can actually be simplified as 95 over 128. Okay, so let's go on and do the iteration 2, step 3. So we're basically gonna get, these are our iterations and those are our values. So we know that x is actually equal to negative 9 over 64. Y is the value we have just found, so 95 over 128, 95 over 128. Z is the value we're looking for, so 71 over 64, and W is still the it still has to be found for better estimation, so 695 over 256. and I'm gonna load only those two, so underline only those two. So we're basically looking for z now. Let's see the equation for z. Well, z has this equation, so 1, which is a scalar, is not dependent by anything, plus 1 over 4 y, so it's dependent by y, plus 1 over 4 w, so it's dependent by w. Z is actually 1 plus 1 over 4 times 95 over 128, which is our estimation for y that we just found here, plus 1 over 4 times 695 over 256, which was our latest, our last estimation for w. So z is actually equal to 1 plus, 95 over 512 plus 695 over 1024. It's pretty fun to work with those values because like 256, 128, 512, 1024, because it reminds me of the megabytes of RAM we had back in the days on our very vintage computers. So again, 1024, so we're gonna have 1024, so 1024 plus, well, this is 190 plus 695, which is gonna give us z equal to 1809 over 1024, so 1024 is our new value for z. So we're gonna go on again, and now we're gonna go to the latest and very last iteration to step 4. So we're looking for w, and then we're gonna stop, and I'm gonna go much farther. So iterations and values in our table as always. So x, we already found x is equal to negative 9 over 64. Y is actually equal to 95 over 128. Z is equal to, well, we just found z, so is 1909 over 1024. And finally w, it was 695 over 256 the last time we were looking for it, and we are just underlining the w because we're just loading the w because it's the one we're looking for, is going to be the only one we're looking for right now. So let's get the equation. Well, the equation for w is actually 5 over 2, which is a scalar, is not dependent by anything, plus 1 over 4 x, so it's dependent by x, plus 1 over 4 z, so it's dependent by z. And therefore, we're basically going to have w equal to 5 over 2, which is our scalar, plus 1 over 4 times negative 9 over 64, which is our estimation for x, plus 1 over 4 times 1909 over 1024 is our latest estimation for z that we had just found. So okay, w is gonna be 5 over 2 minus 9 over 256 plus 1909 over 4096. And now we're going to have w equal to, well, 4096 is going to be totally fine. So therefore we have 10,240 minus 144 plus 1909, which is going to give us w equal to 12,040 5 over 4096. So therefore, after those two full iteration, we've basically got our values as our estimations for x, y, z, and w as negative 9 over 64, y as 95 over 128, z as 1909 over 1024, and w as 695 over 256. So once again, this is basically how it works, and as I show you once again, you can basically start wherever you want. I mean, you can basically pick whatever you want as your starting point, as your starting values, as your starting guess for the values, and then just apply the method over and over again and get the iteration and see to which values it converges to.